They're boarding the ship! Battle stations! Mark, status report.
The Integrand's destroyed our long-distance communications array. We've got no communications.
Balls!
The nearest math fleet station is in orbit somewhere around Newton. We need to jump to get in range of their sensors.
Can we make the jump from here?
Negative. The main reactor was the first thing the Integrans hit. The jump would require more energy than we can get from our warper. We have to rely on our ion drives.
So what are our options?
Well, we could just go the whole distance on our ion engines.
Yeah, but that would take years. Besides, our life support was hit in that fight, and we only have like hours to live before the air runs out.
Wait.
The distance from our current position to planet Newton is 10.77 light years. Our ion thrusters only travel at 400 times the speed of light. So it would take us 236 hours to get there on ion thrusters alone. But we only have 205 hours of oxygen left. There's a warp channel which passes directly past planet Newton, and it's only 4 light years away from us. We can travel at 700 times the speed of light in that warp channel, possibly fast enough to make it in time, but we'll have to be smart about it. We'll have to use math. Using the Pythagorean theorem, we can calculate our distance upstream of planet Newton along the warp channel. It comes to about 10 light years. Now let's take a piece out of that distance and call it x. X will be the position in which we enter the warp channel. We need to find x such that the travel time is as small as possible. So let's start by making a general formula for our travel time in terms of x. Our travel time is going to be equal to the distance that we travel divided by the velocity at which we're moving. Our trip can be thought of as 2 smaller trips, one through static space at 400 times the speed of light, and one through warp space at 700 times the speed of light. The distance of our first trip using our ion drives can be found using the Pythagorean theorem in terms of x. Our trip through the warp channel is much simpler, but can also be found in terms of x. Using these two distances in terms of x, and our given maximum velocities, we can now build our general formula for the total travel time with respect to x. T is our total travel time, the first term is our trip with the ion drive, and the second term is our trip through warp space. And it's all in terms of x, our position where we'll enter the warp channel. If calculus works, then there should be a local minimum at the 0 of the derivative of this equation. If we use our ion drives to get us to that x value, then we should be home in no time. As it turns out, when we solve this derivative, calculus does work, and x equals 1.1925. And if we plugged it into our original equation, it turns out that the trip will only take 201 hours, meaning that we will survive. All we have to do is use trig to find our bearing, and we can start the trip home.
Alright guys, I'm plugging in the last of the equations. We're about ready to go home.
Ready guys? We're gonna warp in 3, 2, 1.